Everybody. So in this video, we are going to briefly discuss a few important terms. And one of them is going to be Starling's law. So all of these terms have to do with the contraction of the heart and the blood flow throughout the heart and into the arteries. So with that said, Starling's law is essentially the strength of a contraction depends on the volume of blood in the heart. Now, we can read all this, and that sums it all up. But I'm just going to go to the next slide here, and I think this will do a good job of helping to understand Starling's law. Essentially this. The amount of blood in your ventricle, so let's look at the left ventricle in particular, because this is the one we're going to be that's used to measure this. If I'm going to do this in orange, let's say the blood is orange here, so you can see it clearly. Let's say we fill the left ventricle halfway with blood, right? The amount of blood in the heart, just like we talked about with the water balloon example, I'll draw that little water balloon over here, right? That's going to create pressure against the walls of the heart, right? So in the case of the water balloon, you put water in a water balloon, it's going to put pressure on the walls on the inside of that water balloon, right? Just like if you put blood inside of a ventricle, it'll push against the ventricle, right? So with that said, you have a certain amount of blood, and then when we push or squeeze the ventricle, it is then going to squeeze this blood out the aorta into the rest of the body, right? Starling's law is just saying this. If you add more blood to the ventricle, it's going to create more pressure. It's going to stretch the walls of the heart more, just as if we had a water balloon, and then we filled it with more water. It's going to create more pressure. And if there's more pressure, then when we squeeze the heart, we're going to move even more blood out to the body. So the more blood, we're going to get more pressure, and that is going to move more blood to body. My little picture. More blood in the heart increases pressure, which means you can push more blood to the body. So that's essentially Starling's law. All right, that's the first of the three terms I wanted to discuss. So if you have any questions on that, let me know, okay? The next two, we're going to do them in reverse order because I think it makes a little more sense. Stroke volume. All right, this is an important term. Stroke volume. This is the amount of blood that is pumped from the left ventricle, just like we showed in the last picture, to the aorta per heartbeat. So if we go based on Starling's law, we can change that, right? So if you have more blood in the ventricle, you're going to push more out, right? So if we measure that, that is by definition the stroke volume. How much blood per heartbeat is being pushed into the aorta? That's about right. That's about it, right? Now you can use stroke volume to calculate cardiac output. So cardiac output is how much blood is pumped from the left ventricle, just like stroke volume. However, it's per minute. So let's do this as an example. Let's say, and I'm making this going to make this number up, right? Let's say stroke volume. The stroke volume in an animal's heart or a human's heart, I'm just going to give it a completely random value. All right, so do not think that this is specific to a human at all. I'm just going to give you a nice round number. Let's say the stroke volume is 10 units, right? So 10 units of blood, okay, per beat. Now let's go up to stroke volume. I'm sorry, cardiac output. So that would be your stroke volume, 10 units per beat. Cardiac output would be 10 units per beat times however many beats there were in a minute. So let's say there were 10 beats in a minute. What that would mean is your cardiac output would be 100 units per minute. So you have to do some math for that one. Stroke volume is just how much. Cardiac output is how much in a given amount of time, so per minute. So that's important because you can calculate how much a person is actually pumping every minute. If you have any questions on these terms, just let me know.